So in physics, in addition to the English alphabets, uh, to represent the elements, quantities, different Greek alphabets are also used. So you should be well known, well versed about these alphabets. So these are the Greek alphabets, important Greek alphabets which are most commonly used in the physics. So first one is alpha, beta, gamma, delta, epsilon, eta, theta, lambda, mu, nu, pi, rho, sigma, like this or like this. Both symbols are used in the physics. Then phi, this one. Then omega. Omega is also having two symbols like this or this. These two symbols are used in omega, Greek alphabet. So now we are going to learn about the prefixes. These prefixes are also the most important part in the physics, where especially when you are solving the numerical problems. At that times you may need these prefixes. So let us know about it. 10 to the power of plus 1 deca, 10 to the power of plus 2 hecto, 10 to the power of plus 3 kilo, 10 to the power of plus 6 mega, 10 to the power of plus 9 giga, 10 to the power of plus 12 tera. Likewise, 10 to the power of minus 1 deci, plus 1 deca, minus 1 deci, 10 to the power of minus 2 centi, plus 2 hecto, minus 2 centi, 10 to the power of minus 3 is milli, 10 to the power of plus 3 is kilo, 10 to the power of minus 6 is micro, plus 6 is mega, 10 to the power of minus 9 is nano, 10 to the power of plus 9 is giga, 10 to the power of minus 12 is pico, and 10 to the power of plus 12 is tera. Now, this symbol milli, the symbol is small m. Small m will stand for milli, 10 to the power of minus 3. And this mega is having the symbol capital M. So capital M will stand for mega m is 10 to the power of plus 6. And this 10 to the power of minus 6 macro is symbol is mu. We have learned this Greek alphabet mu. Mu is the symbol for macro, 10 to the power of minus 6. Now we are going to learn about the important constants. So these constants are very much important, very frequently used in solving the numerical problems, and these values you must have to remember. All the time you cannot go through the books and see the values and use the values. These values you have to put the efforts and memorize it. Important constants. Speed of light in vacuum, that is c, and its value is 3 into 10 to the power of 8 meter per second. Second one is charge of electron, and the symbol is small e, and its value is 1.6 into 10 to the power of minus 19 coulomb. Then gravitational constant, capital G, and its value is 6.67 into 10 to the power of minus 11 Newton meter square per kilogram square. This is capital G. Small g is acceleration due to gravity. Its value is 9.8 meter per second square. Planck's constant h. Its value is 6.6 into 10 to the power of minus 34 joule second. Avogadro number and subscript A, 6 into 10 to the power of 23 atoms per mole. This units, if you don't remember, also not an issue, but you must have to remember these values. Mass of electron is small m and its value is 9 into 10 to the power of minus 31 kilogram. This must you have to remember, this value is in kilogram. Then you see this is the charge of electron is E and then mass of electron is m. Sometimes charge to mass ratio, that is E by m, is asked. So instead of memorizing the value of E by m, we suggest that just this is enough to memorize these two values and then you can divide these two values. So you will get the ratio of charge to mass of electron. Permittivity of free space, its symbol is epsilon naught and its value is 9 into 10 to the power of minus 12 coulomb square per Newton meter square. Permeability of free space, its value is mu naught 4 pi 10 to the power of minus 7 Tesla per ampere. And here epsilon naught is 9 into 10 to the power of minus 12 coulomb square per Newton meter square. And 1 upon 4 pi epsilon naught. If you put the value of epsilon naught here, then you will get this result of 1 upon 4 pi epsilon naught, 9 into 10 to the power of 9 Newton meter square per coulomb square. Now the eighth one is permeability of free space. Eighth one I will write here. Permeability of free space. Its symbol is mu naught and its value is 4 pi into 10 to the power of minus 7 Tesla meter per ampere. Tesla meter per ampere. So note down one thing. Here we have used the approximate values, not the exact values. It may be 1.60 something, but that very small values we have neglected. Like this here also you can find after 6.6 something will be there, 2, 5, 4, 3 like this. So everywhere you will find the values, smaller values. But we have neglected that smaller value because when you are solving the numerical problems in the Neet, in 1 minute you have to read the question and you need to solve the question itself. So that small and big numbers, small calculations we cannot do in short period of time. We need to take the approximate values, find out, do the calculation, and your result will be the approximate result. And just you need to choose which option is very close to your answer, and that will be your final selection.